So for my edification, go ahead and raise your hand if you would consider yourself a developer. That's what, almost entirely the room. Raise your hand if somebody else would call you a manager. Nobody willing to admit to it? All right. UX, QA, a couple people. There's always, both of those always just like half hands, like you're ducking all of the developers you don't want them to know. Product owners. Maybe a couple, okay. Manager, I said managers already, so. All right. Well, we're gonna try to take some pot shots at everybody today, so hopefully we piss everyone off equally. Today we're gonna talk about boredom-driven development, the dark bargain at the heart of software. That's me. I'm Arthur, or Art, take your pick. I am aggressively neutral on the topic. Typically, this is the slide where I tell people that I am not a neurologist or a psychologist or a therapist in any fashion, because I'm usually about to spend an hour talking about brains. Today, we're really talking more about software methodology, and unfortunately for you, I've been a software developer, paid to be a software developer for 20 plus years at this point, so I will crumble into dust before your eyes any moment, surely. I work here at Avature. If you've heard of us, we're like 132nd Giles. It's one of the few places I give talks where somebody might go, oh yeah, I actually know where that place is. They don't know this in Belgium, they don't care. But they come and do cool things like give talks, so they get slides. All good talks start with a story, right? So let's kick this off. As a developer, you open the requirements doc for the next client application and you sigh. Yet another data over web forms app, same as it ever was. All anybody ever wants or seems to want is basic business automation. Get rid of paper, enter it on a screen, funnel it into a database, build some basic reports around it, yawn. How, in the name of God, are you going to survive the endless slog of the next 6 to 9 months? How are you going to survive the endless parade of tickets created by your product owner? How are you going to survive building feature after feature where the ticket might as well just redo exactly the same thing you did but for a different domain object this time? How are you going to survive building client-side and table-side or server-side table filtering for the 700th time? How are you going to survive hours of planning and refinement on tickets that just do absolutely not deserve it? How are you going to survive arguing over endless validation problems in one specific field, in one specific form in your application that literally no human being is ever going to see? Suddenly, an open browser tab catches your eye. Wait a minute. That new framework from that big corporation, that new hotness I just read about, that's going to solve some of my problems. Now, it's going to cause a couple problems later too, but that's not going to be for at least 6 to 9 months. So I should be fine, right? But it's more modular. And, you know, they might want a mobile app after all. And if they want a mobile app, then they might want a PWA. And if we're going to do that, then we absolutely have to go local first. And at that point, we're building so many front ends, we absolutely have to go with the latest CSS framework du jour because we need to standardize, obviously. And then, of course, we have to specify, or the client rather doesn't specify anything about the delivery and service on this thing. So we're going to containerize all of it. And that will, of course, simplify our build pipeline and the DevOps pipeline. And that, of course, means we're going to use Terraform so that we can be deploying to multiple environments and multiple AZs easily. But if we're going to do multiple AZs, then we might as well just go whole hog and deploy to Google and Azure at the same time as doing basically every region inside of AWS, just in case. And then, of course, nobody likes writing YAML. So what we're going to do is invent yet another YAML generator and put a thing in so we can write in real code, and then it will generate YAML for us to shove into Terraform. And then, of course, why not just slap Kubernetes in there while we're at it if we've got so many containers running? Because that'll let us load balance these containers, right? You know, they only have 7 employees at this company we're working for, but it'll be fine. And of course, that will make things future-proof. And we might want to turn around. The client might at some point want an ETL platform and a whole ass data warehouse. If we're going to do that, then we might as well build the BI portal for them. Now, they don't have any data scientists or anybody that knows how to build like columnar data flows, but it'll be fine. They'll have it for the future. It'll be great. Look at this wonderfulness. And then, of course, we're going to forget observability and accessibility until the absolute end of the project, despite knowing that we should have done it from the start. So we're going to Band-Aid that in, and then have to cram everything in with a bunch of things that basically look like console logs, except we're spending a lot more money to do it. You now know how you're going to spend the next 6 to 9 months. You are going to spend it overwhelmed. You are going to spend it reading through documentation. You're going to spend it looking through external sources, working through stories to lay down all of this infrastructure that you've just spec'd out, having endless arguments with people on your team about technologies that you didn't even know existed a week ago. You're going to be overwhelmed. Your software is going to be overcomplicated and over-architected. And the client is going to be very confused because it looks like you were working really hard to build something that's actually fairly simple looking on the other end of it. But you're not going to be bored, so you've got that going for you. Now, in software, we tend to call this a specific term, this behavior that we've seen. We tend to call it resume-driven development, under the idea that people are picking and choosing these technologies based on what they want to go learn next, what they think will propel them for a better job or keep them more employed at their current job. But realistically, I think what this behavior is it's boredom-driven development. Our deep-rooted fear of being bored is what propels us to make these choices. And our brain happily provides a narrative that justifies all of these actions. How did we get here? What is happening with our brains, with boredom, and how does it work its seductive magic on us? Perhaps more importantly, why are we bored with software engineering? What has happened to us, and what has happened to this industry? And explain how we got here, we have to do the stupid podcast trick where we take you back in time and talk about the history of software as a job and hopefully pinpoint the moment when we made the dark bargain that put us in this position. So we're going to start at the beginnings, the very beginnings of software. And I wish we could spend more time here. There's so many fascinating things going on in this period. There's Babbage, right? There's Claude Shannon, there's von Neumann, there's Colossus, there's ENIAC and EDVAC. There is just an infinite amount. We'd spend hours just talking about all of the cool things going on in this period in time in history. We don't have time for it, so what we're going to do is talk about two specific things. First, computers used to be big. I mean really big, like rooms, houses size. And the reason for that was because at the start, Colossus in Bletchley Park, they used mercury switched valves for actual memory, for bits. And then eventually, people got wise and they started using vacuum tubes. That is a debounce circuit from a 1954 IBM mainframe. These cost a lot of money, they broke a lot, and they were very big. But here's the other thing we have to remember about this era. People realized that you could use software and computers to win wars. And nobody cared about it until that point. This is a 1938 a torpedo vector calculator, like trajectory calculator. It's an electromechanical device, actually. One of the first things that we actually started using these devices for, beyond just simple basic accounting and adding things up, was trying to blow other people up with them. And of course, Bletchley Park itself in World War II is a perfect example of that, using the Colossus to decode the Enigma machine to figure out what the Germans were saying. Massive, incredible spending, huge leap forward in software entirely funded by governments to win a war. The conjunction of these two things, computers being slow and problematic up front with massive amounts of government input, leads us to the invention of this guy, the transistor. Transistors plus the post-war economic boom mean a massive outlay of computers. People are building these things, they're getting faster and newer all the time. And they take less time to build, they take less room, and they break less. So now we hit the first portion of this talk that's actually about the job of software, the beginnings. After the war, computers aren't everywhere yet. But they're really starting to get into a lot more places, especially universities. And so, you have a bunch of people trying to explore, academics exploring what's possible. There's a very Renaissance attitude happening at this moment. At the same time, actual companies start to emerge to take advantage of this stuff. Applied Data Research holds the record for potentially being the first company actually to get paid to produce software. They produced that thing, which is it's called AutoFlow. It produced flowchart diagrams in ASCII. That was the thing. This is a world of possibility, a paradigm shift. People aren't certain what's going to happen, but here's the thing. It's also a world where there's just not enough computer to go around right now. If you are working with a computer, or lucky enough to be able to work with a computer, especially in an academic setting, you have like a time that they assign you that you will actually get to go and work with the computer. And usually this involves pre-punching a whole bunch of punch cards, running the thing in, and if it doesn't work, you're out of luck, you're screwed. So, what that means is there's a lot of downtime, a lot of boredom for these people to spend on things that they care about. Now, psychologically, boredom is kind of a squishy thing. It's one of those things that psychology has a problem with where it's so common that a lot of people don't study it because it's not really big or flashy or interesting. It's just there and we all experience it. But if you take a bunch of the different definitions and kind of scoosh them all together, what you get is boredom is an unpleasant affective state related to the inability to sustain attention. Which is to say, you have a want or desire to pay attention to something and you can't for some reason, and you feel bad about it. Now, you can break that down into three different kinds. There's thwarted engagement of attention, forced engagement of attention, and inability to sustain attention. Thwarted engagement of attention is basically, you want to pay attention to a thing, but I'm not going to let you. Forced engagement of attention goes right alongside of that. You have to pay attention to this other thing. When people are externally directing your attention, the odds of getting bored are higher. The third kind, apparent freedom with inability to sustain attention, is the one we're more commonly associated with boredom as a word, where we have the ability to choose, but we just can't pick. We can't decide which way we want to go for whatever reason. So when programmers are forced to spend hours waiting for their programming slots, they can't focus on their want to, right? That's thwarted engagement of attention. So their brain in this negative affective state goes, oh, we got to find dopamine somewhere else. Let's go spend some time and think of something else. They're looking for something else that can sustain it. And most of the time, those things are novel, new, exciting, because nothing is as addictive to your brain as surprise. Turing himself wrote a chess program for the Colossus that he was never actually able to run. That's the level of boredom that these people were driving to, of like, I'm just going to write a program and I have no idea if it even compiles, but this is fun to do. That was the era of programming back then. Now, a lot of those replacement activities were self-directed, something they were interested in. And so this habit, this pattern of boredom and self-directed activity goes until we hit the next kind of phase of software, the industrialization. In this portion of time, companies who are working with hardware and software start to want to pretend. They look at the history of software and they want to believe that software, this weird little gremlin, has more in common with the long history of industry that precedes before it, of understandable, predictable, regular industry, and nothing to do with its other parent, mathematics. And the thing about that is, partially they were right. Again, because computers were so sparse and so infrequent, and because you had to wait so long to use them, the cost of a failed compile was actually very high. And so you get these moments where companies start to want consistency. And more importantly, they start to want control. This is the era that brings us the waterfall methodology. If you've not read Royce's 1970 waterfall paper, the one everybody talks about is this. That's the first diagram, and he walks past that like almost instantly in the paper. This is the full waterfall diagram at the end of the paper where he's like, yes, we need to do all of this, and also we need to do the job twice if possible. Thumbs up. What Waterfall was intending to do, the intent that Royce was shooting for, was to avoid lost work. Because computers were not as fast as they are now, not as cheap as they are now, not as ubiquitous as they are now, they were working to try and ensure control over software. Also, in this period, we start to delineate between the people doing the work and the people organizing that work. And if you want to understand why we do that, we unfortunately have to go even further back in time to 1910 to talk about this guy. Anybody know who this is?
Taylor.
Thank you. Nobody in Belgium knew who this was. They thought it was Ford, and it's like, no. Frederick Winslow Taylor. Frederick Winslow Taylor is the father of something called scientific management. And to be fair to him, it was revolutionary. Prior to Frederick Winslow Taylor, most work looked something like the following. You started as an apprentice under a master. They taught you their techniques, their tricks, their process for building a thing. A lintel, a stone lintel, a wooden gear, a horseshoe, a rib for a sailing ship. It didn't matter what it was. They had their techniques and tricks. And then they taught them to you. And then you were expected to go somewhere else, not competing with your master, and then ply your trade there. The entire medieval system of guilds was arguably organizations dedicated to protecting intellectual property. In fact, so that if you did not come up in the guild under a proper master, if you were using techniques that they thought you were stealing from them, they would come down on you like a bag of bricks. Now, this is inefficient, all right? We're not talking with each other. We're not working to find the best processes. We're not working to find what is most efficient, setting aside the argument of whether that's the right goal or not at the moment. But this was actually preventing a great deal of progress, in air quotes. But real progress, realistically. Things like assembly lines weren't even really cutting it because you didn't have a standardized methodology to understand how to do the work. This is what Frederick Winslow Taylor set out to fix. He's one of the first people in recorded history that set out to study work. That he thought, he was one of the first people to think work was worth studying. And to be fair, it is. I just wish he hadn't been such an asshole about it. The 4 tenets of scientific management are this. 1, replace rule of thumb work methods with methods based on the scientific study of the tasks. All right, that makes sense. Scientifically select, train, and develop each employee rather than passively leaving them to train themselves. Okay, I appreciate an active training regimen. 3, provide detailed instruction and supervision of each worker in the performance of that worker's discrete task. All right, now you're losing me. 4, divide work nearly equally between managers and workers so that the managers apply scientific management principles to planning the work and workers actually perform the task. And this is the point that has screwed us. This is Frederick Winslow Taylor's problem, because what his scientific management sets out is that the job of the manager is to figure out how to build the thing, to look and say this is the most efficient way to perform work studies, motion analyses, efficiency analyses, and to say this is now the way we build this part. And now, having done all of this creative work, it is now your job to build the thing. Frederick Winslow Taylor effectively set managers apart from the rest of the workers. The managers decided what work would be done, and the worker's job was to do that work, to execute on the plans. Now, he considered this to be equal share of the work. And everyone in this room who is used to doing creative knowledge tasks understands that all of the interesting work now lives over here, and all the dumb work lives over there. All that creative labor is at the management level. There's a reason for that, and it's that Frederick Winslow Taylor was a eugenicist, among other unsavory things. His methodology and mindset actually worked its way into U.S. schools through his pupil, Edward Thorndike, also a charming man. Both of them big fans of Francis Galton, if you know who that is. The entire bell curve system of grading is intentional because what it does is it sets up the hierarchies that exist in a Taylor factory. Your managers are going to be your A-level students. Those are the people you want to send to college. Those are the people you want to actually spend money and resources and time on. F students, screw them. D students, all right, yeah, okay. The C students, those are the ones we want to get through basic education. Maybe high school, but probably not. They don't need high school to work on a factory line. These are going to be your workers, and all the smart people are over here, and that's where we're spending our money. Screw the rest of them. That's very explicit in the way they lay this out. Now, the one difference between Frederick Winslow Taylor and what he was doing with industry and this era of software is that to managers of this era, software is dark magic. They straight up do not understand it, perhaps cannot understand it. And so to them, software developers, or mathematicians or programmers or whatever they called them in that moment, they're magicians. They're weaving these things, and it's very difficult to understand what is happening from a managerial perspective. And so they turn to the teachings of this asshole. Anybody know who this is? That's a new face for you to, yeah, it is an asshole. That's Peter Drucker. Peter Drucker's greatest hits include the KPI and the OKR. The KPI being the key performance indicator and the OKR being the objective and key, objectives and key results. There we go. Drucker, he's a management hero. They still teach this guy in management school. And the reason why is because his whole innovation was that you do not need to understand, innovation in massive air quotes, you do not need to understand the process that you are attempting to change. His theory is basically that if you understand the inputs to this process and you understand the outputs to this process, as long as you look at both of these, if you change these, you observe the resultant change in the output, and you don't have to understand what's going on in the middle. You literally don't have to know what's going on with software, how to code it, a compiler, if there is a compiler at all. You don't have to understand binary or information theory. All you know is that you did this, and you got what you wanted out of it, or not. So they're trying to reduce programming, Drucker style, to measurable outcomes. They're doing that by things like breaking it down into the smallest units of work and handing those out to increasingly interchangeable developers. The absolute apex of this era, especially visually, I view as the 1982 movie Tron, which uses an endless cubicle farm and the color blue, actually, to represent alienation and corporate, just the draining of joy out of life, basically, especially when viewed against Flynn's arcade, which uses red neon and exciting red colors. And then once you get into the grid, they actually flip those colors around. Don't get me started on Tron, we'll be here all day. But this presages the next era of software, which is the commercialization. Because this is the era when software starts to eat the world. PCs start to drive computing to the edges in a term before they understood, or an era before they understood what that term actually meant. You have a rapid decentralization of compute. And this allows people to actually play around with computers. You can now design, write, and compile and run code on your own machine. What that means is that the nascent hobbyist scene that was puttering along in the 70s and early 80s, soldering together their own computers from companies like Heathkit and Honeywell, took off like wildfire, because now you don't have to do all that work. You just plop a computer down in front of you. If you didn't put a disk in an Apple IIe, you got a basic compiler, or interpreter rather, that, of course, you couldn't go back and edit previous lines on. Ask me how I know about that one. But you didn't need anyone telling you how or what to program. And so you wind up with this generation of people who actually like to program. They view this as an interesting, exciting activity because it's self-directed, because they're letting their attention wander onto something new and novel, just like all of the people working in computer science back in the 50s and 60s. In addition to this, most jobs start to involve some form of software. We start seeing people having to connect to mainframes for their job, using Apple IIes, using basic spreadsheet programs, et cetera. Lotus Notes, right? Lotus 123, huge, huge company. But the dynamic of control has also evolved. It is becoming rapidly clear that companies cannot centrally control all of their software. There needs to be some level of autonomy in the hierarchy of control. Enter the business analyst. Now, the poor business analyst did not start out as a business analyst. Ooh, that went right in my face. The business analyst started out as a systems analyst. Their job was to look at the system, optimize the process, optimize the flow and how things fit together. But their ability to look at the system actually kind of screwed them. Now, a common practice in the 1970s was actually to kind of stack rank your people coming in. You had them take a logic test. If they scored low enough, they were QA. If they scored mid-range, they were developers. If they scored really highly, they were systems analysts. These were the people who understood the most about it, and more importantly, they were capable of talking about it to people that weren't technical. Now, everybody on that management side of the line looks at this and says, wait a minute. You can explain this to me. Now, I think you are cool. You're on my team. And so they ejected them between the client and the developer. The poor guy from Office Space who says, I take the things from the client and I take them down the hall to the developer. He's a business analyst. That was their job, is to take those pieces of software or requirements, ideally translate them into something technical because they had that ability. But the thing is that they're an avenue for company control. That's entirely what they're there for. And this means that we are now in a very, very interesting moment because the programmers of that age enjoy programming, much like we do. They enjoy solving logical problems. They enjoy puzzle solving. They enjoy engaging in the work of building digital structures. And so now you have these people coming into this process that can talk technical, understand technical, but are also on that management side of things. And to these developers, the business analyst represents an existential threat because this is a person who might actually be able to tell you you can't play the creative games you've been playing with software. You've been able to enjoy programming because the people managing you don't understand it. Now we're at a stage where they can full-on Frederick Winslow tailor this thing. And so they realized they needed to protect themselves. And so what they did was they struck a dark bargain. They ceded the opportunity to control what they code in order to retain control of how they code it on a technical level. Every moment from here on out is a result of this bargain. The proliferation of a series of technical roles that mirror the non-technical roles on the other side of the business, that's a result of the bargain. The wall between these two groups, the very idea that to be business focused and to be technical are two opposing sides of the same coin, that you cannot be both, that there is a fundamental separation between the two, it's a result of this moment, this bargain. The Taylorist view that you need not bother yourself with what it is you are accomplishing with your code, that you just need to sit the hell down, shut up, and write your widget, is an outcropping of this moment, of this dark bargain. The idea that to be technical means that you shouldn't have control over the outcomes and uses to which your code is put. That's actually also a moment, an outcropping from this dark bargain. And after the bargain is struck, the technical side of the industry just vanishes inward into a vast abyss of navel-gazing technically. We start focusing on all of these things about the technical aspects of our business and things like process, et cetera, things like how do we actually get the code to build. The era of where we're having discussions over thousands of languages, hundreds of languages, which one's best? Are we doing Java? Are we doing this nascent .NET thing, et cetera? This is that era. Now, I want to be clear, I don't fault our ancestors for this moment, all right? They were faced with possible extinction, and they took what they could get. And to be fair, a lot of these people were very young in that moment, and they simply didn't understand what they were giving up. They thought that all they wanted to do was program. And to be fair, in that moment, that might as well have been true. But things keep changing. The internet happens, and first the internet happens very slowly. It happens with modems, and then BBSs, and then Prodigy, CompuServe, Usenet, and then all of a sudden the browser is born. Mosaic exists, and the internet is real. And then Netscape happens, and it's hugely popular, and then Netscape has the biggest IPO in history. And then everyone loses their goddamn minds. Everyone suddenly wants to be a startup. Everyone wants to be an internet darling. Everybody wants cut of that green. There's a lot of money going around. Although, to be fair, the current moment makes that, look like a church dance, basically. And realistically, how much you could expect to change people's lives did change in this moment. You no longer needed massive capital, huge amounts of computers, and a whole bunch of things, you no longer needed hordes of salespeople to push your software into people's lives. You could code an app, a website that could actually go out and change people's lives. And you could do it in your dorm room with your friends, with a hefty round of initial seed capital from your friends and family, and that dorm room happens to be in Cambridge or Princeton, but it's fine. And the internet goes crazy. We hit absolute peak internet. Well, peak pre-bubble internet anyway. Everybody is racing for that biggest IPO. And what happens is that everybody's so freaking crazy about the money, nobody really notices that a weird thing has occurred. That you have a bunch of these companies that are fairly big companies in a lot of cases, things like Microsoft, things like Apple, where the people running the business are actually technical. That the people doing this work actually come from the side of the technical work. There's actually been an erosion of that wall between the business and the technical side. And without anybody really noticing, because everybody's so focused on the internet being a thing and the money being a thing. And is pets.com gonna, what's their next Super Bowl ad gonna be with $3 million? And it is into this moment that the bubble pops, and suddenly people are like, wow, well, I guess that internet thing was cool. We're done with that, right? Into the moment, the vacuum left by the bubble popping, a bunch of people suddenly step forward. And they have been thinking very hard about software. And they've been thinking very hard about how to treat software like it's software instead of like it is industry. They want to treat that little gremlin like it's itself instead of like it's something else. They're trying to find a more flexible and nuanced methodology that is focused on value. They are trying to find a methodology or promote a methodology where knowledge is created at the edge of a company, at the edge workers doing the actual work, and the direction for that company is pushed down from the top, and it is synthesized into meaning from both directions are synthesized into meaning by the middle management level. That this idea of a company, that their job is, job of a manager is to synthesize information, to create meaning, not to dictate anything. They're trying to refocus the industry on value and on outcomes instead of on output. They are trying to free us from the dark bargain. I view the Agile Manifesto as really an exercise in attempting to find the correct line between focusing on what and focusing on how. Because again, they're in this moment where that is a lot more fluid in a lot of these companies because the wall has been eroded. Now, we're not the first industry to have to deal with this problem. And have you ever read this book? Half? Okay. Most people say no, but this is a pattern language. If you have read the Gang of Four Pattern Library, their book, it is based on this. The entire concept of a pattern language comes from this book. And this is about buildings. Well, realistically, it's about societies and then countries and then cities and then communities and then buildings. It's a really fascinating book. It's also freaking huge. But I was reading this book and I realized something, that like 4/5 of it is taken up by what we should be building. And really only the last fifth is concerned at all with how to build those things, like the construction methodology, the preparing of the terrain. All of that's over here in the how, and there's barely any of it compared to things like, hey, you should be building seats by windows because people like to sit by windows. The patterns they considered most important in this book are the what. Additionally, at this point in time, the cost of a failed compile is drastically decreasing. You know, if you can run, you type, compile, run, program, and check programs on your own machine, it's a lot faster. Compile errors at that point are basically speed bumps. All of that paired together with a team that is properly empowered by Agile means that an Agile team can actually be very autonomous. An Agile team, truly like really capital A Agile or lowercase a Agile, depending on which, the one that isn't Scrum, is empowered. They are able to discover work, to refine that work, and to execute on that work. Whether that is directed by a central ethos of the company they're working on, or whether it's entirely independent. An Agile team is free of that dark bargain. In that moment, in this time, we were almost free. But then somebody got the hot idea that we should sell software as a service. And everybody wanted to start to deploy to the web. Everybody wanted to start doing exciting, interesting things for some money on a regular basis. And unfortunately, the web is a teetering pile of nonsense cobbled together by horrible gnomes. And what that means is, well, and mobile is even worse. So what that means is that you have to actually spend time building out, or can spend time building out things to kind of make this a little easier and saner. And yeah, I actually do have to explain to people when I go overseas and talk, I'm not the guy from Nebraska, like that's not me. Because they're like, you're the guy. I'm like, no, that's somebody else. What you have in this moment is this era of creeping complexity. And it presages the next era, the next change, which is venture capital and the death of Agile. Because here's the thing. If you are a Drucker-trained manager, Agile teams are your kryptonite. They are terrifying. And the reason why is because Drucker is a Taylorite. He has been since the beginning. The man loved that dude. Like, okay, Peter Drucker described Frederick Winslow Taylor as the Isaac Newton of work. That's not a thing you say about another human unless you're like really deep in the bag for him, okay? And he doesn't believe in this degree of control. And so the business people of this time start to complain. Our BD teams have made 6-month commitments. We have to plan. We have to know if we're on track. How are we supposed to know where we're at? How are we going to achieve the growth we need to get more money from the venture people that we wasn't supposed to say that part out loud. But how are we going to meet our metrics, our OKRs, if we don't have a more rigid methodology? And so management performed an embrace, extend, extinguish on Agile. And they did this with Scrum. Because Scrum has a lot of things to say about the process and the business, and has very little to say about the technical side of things. And the thing about Scrum, if you're actually paying attention to it, is that it pushes a bunch of what's considered unacceptable work of thinking about the user and reasoning about what they're actually trying to achieve. Because I have to tell you, if you're looking at a user story that says like, as a user, I want to log into your website, that's not a user story. That's just a ticket. A user story is, as a user, I have 3 screaming children and I need to order dinner. That's a user story, okay? You can't think of the software without thinking of the people using it. And so what you end up with in Scrum, though, is a dilution of that. Scrum pushes this unacceptable work into acceptable work, meetings about refinement and acceptance criteria and getting our certifications for Scrum certifications. That's how they perform the embrace, extend, extinguish on Agile, by embracing the terms and the terminology and killing it. Absolutely, we can have sprints. It'll be fine. No, points aren't ours. No, never. Measure velocity is an absolute. We would never dream of it. It'd be fine. All of it lies. Every last minute of it. They were out from the beginning to kill this. And the apotheosis of this is SAFe. The Scaled Agile Framework, which if you're familiar with it, I'm sorry. It's not the only thing of its kind, but it's really been the most successful. And to developers, SAFe is an open door on a trap. Oh, it'll be okay. Look, you don't have to care anymore about the hard stuff. Just come back in here, it's safe. You could just focus on your little technical stuff. It'll be all right. We got the other things. All you need to worry about is the code, and you don't have to think about anything other than the code anymore. And so we willingly walked back into the dark bargain as an industry. Product owners are really just the new BAs. They're basically just pre-digesting work for developers, and in the process robbing us of autonomy because they believe that we aren't people, so we can't understand it. And the thing about it is that software isn't punch cards anymore. Like, that's really the big problem here. Software isn't even really maintaining your own internal libraries anymore. What we do is largely getting bits of data from one place to the other through a bunch of different open source hops, maybe with a tiny bit of business logic in the middle. We're basically digital plumbers, and most of the time the pipes are really freaking straight. And the thing about that is that it's boring. That a lot of the how is boring work anymore. What we are doing is stuff that is not intellectually engaging. This is the stuff that causes us to perform that novelty-seeking behavior I was talking about at the beginning. This is the stuff that drives us to overcomplicated solutions, over-architectured, over-engineered, and unstable solutions because we overcomplicate our work to the point that it becomes intellectually interesting to us again. We're not alone in this. There's definitely some people pushing it and ready at any moment to provide us with things because the huge companies, the hyperscalers, have produced a series of tools that they needed, to be fair, in order to manage the sort of scale that they have. But because they think that they're cool engineers and because it's really good PR for them, they open source a lot of these things. They fission it off. They make it available for all of us to use. And that's an endless treadmill of novelty for us to start chasing down. As they pivot, to whatever the new hotness is that they're actually working on. And the list of these is long. The various framework wars in JavaScript, server-side versus client-side, which I think we're due back for another server-side swing. DevOps, DevSecOps, Web3, the metaverse, NFTs, it doesn't matter. All of these things, even if they have actual value, are to an extent a distraction. Even if it is worth doing some of this work, none of this work is user-focused. It is entirely developer experience-focused. And we as developers tend to hyper-focus on the exceptional. We look for the edge cases. We look for the random things that are going to happen. What about this? What about this? Our job literally trains us to do that. And to be fair, I think a lot of people who do that naturally wind up in tech. We don't experience our software as our users use it because our product owners and our clients keep us from them. Keep us from seeing how a user is actually using our software, which means we're going to underthink how they use it. Because I have news for you. Humans are infinitely creative when it comes to gluing together pieces of solutions into an ad hoc quilt of madness that they run their entire business on top of. And then on top of that, with an endless push to do more all the time constantly and meet our velocity, if that's even a thing that makes any sense to say, we ship MVPs now, which basically just means we do 80% of the work and then we don't bother doing the rest of it. And the software we build continues to get simpler and simpler. Software has to be intuitive now. And if we're ever going to expose complexity to a user, I challenge you to find a piece of software that exposes complexity to you that doesn't do it through some kind of API. And then, on top of all of that, software is freaking everywhere now. It's become unbearable how much software there is in every single thing that we touch, and it's all so needy all the time, constantly. And it's getting worse. Corporate consolidation, monopolies, monopsonies, and shitification, it's driving burnout in us, it's driving burnout in the whole industry, it's driving burnout in average people having to deal with the things we build. And if that wasn't bad enough, there's actually this whole concept of bore out where you can get burned out by being bored enough. Great. And of course, in the last couple of years, the fate of our industry has had a kind of question mark hanging over it. So, how do we move beyond this moment? What is it that is going to propel us forward? Because right now, the dark bargain constrains us. We, as engineers, are trying to do the work without understanding the work. And I don't mean that we don't understand the tickets or the acceptance criteria in them. I don't even mean that we don't understand the technical solution part of it. What I mean is that we don't have a clue what they're actually trying to get done most of the time. What the actual human users using our software are trying to accomplish with that software. We're shipping a piece of software because somebody put it into the QI planning for the PI planning for our safe iteration this quarter, and we have to get that done because somebody's got to hit their OKRs or they're not going to get their bonus. We allow the dark bargain to rob us of curiosity about the goals of the users because it's easy to sink back into that cadence of tickets, of sprints. That's arguably one of Scrum's worst qualities, is that it has an alluring cadence that makes you feel like you're doing work. So what is it a problem if we don't have curiosity? What does that matter? Well, here's the biggest problem. Most of us enjoy software. Most of us have mingled our identities as developers with our identities as who we are as a person. We consider ourselves part of our job. In fact, you might consider yourself a particular language developer, which is really kind of weird if you think about it. That's like a carpenter being like, I'm a Phillips screwdriver guy. Can I get you to do another one? Nope. We have our identities tied to this skill that we very much enjoy doing and that we're one of the only people that can do. And the problem with that is that it seems reasonable, but it ties us into this loop. That for us to get dopamine, we basically do something technical and then we have that solution at the end of it, right? We may not enjoy this part, maybe we do, but we enjoy having coded. We enjoy technically having the answer, the problem to the puzzle, to the solution, or the solution to the puzzle. This doesn't work when the work isn't engaging. When you're just gluing together bits of code that somebody else already wrote to get this thing across the line, it's not technically interesting. It doesn't scratch the itch in your brain of saying, I have accomplished something worthwhile. So we have to move up an abstraction layer is the solution to that. We need to build our ability to feel satisfaction in taking an actual user need, doing the technical work, and then seeing that manifest in the real world as somebody getting their job done or having a better day. This is the thing that's going to save us. Even if that code isn't up to snuff, even if the developer experience isn't that great, this is the thing we need to focus on. We have to do the work of ensuring that the technical solution meets an actual human need. This is work we usually push off to a product owner, or at best to UX. Understanding our user and their goals needs to be a whole team responsibility. And we have to allow our users to build competence in our software. We have to have a degree of trust in our users that they can understand complexity, given time, given help, given hints. And if you doubt that users want that, I would like to present to you a single piece of software that will convince you otherwise, Microsoft Excel, which runs more businesses than you should be comfortable with, and also has an esports league. Did you know that? It's a thing. It's freaking terrifying. This software is unfathomably complex. People use it every day, and they don't enjoy it, but it gets their job done. We need to become more holistic as engineers. Every single one of us, every technical skill that we bring to the table needs to be used in the service of being a product engineer, a solution engineer. All of these things have to be in service to the user, or they're just not that useful. And not in the service of the people cutting the checks either. We have to push past them. We need to understand how to get to the people using the software, because most of the time, the people cutting the checks, and I can say this having been a consultant for 12 years, the people cutting the checks do not understand how the people below them are using that software for real. They have an idea in their head and it is like maybe 30% right at best. Now, all of this is made even more important with the thing I have spent most of this talk kind of dancing around, like not wanting to talk about it. LLM assisted coding. The people that know me are like bracing. Let's take an optimistic view, all right? Let's assume that the work of writing code is now largely going to be left to the agents. The work of producing lines of code is now largely not a thing we will be doing. It makes the rest of my talk even more important. We're just going to be even more bored. Like if our job becomes arguing with an idiot to write the right code for us, that's even more dumb. Like we're going to spend even more time being bored and overcomplicating our lives. It's like, well, I'll just invent another agent that's going to argue with this agent for me, and then this agent will argue with this agent. And now you've got squad, right? You have to move upward in that loop, because if agents are doing that bottom technical loop, it's not available to you. You have to move up to the level where you are actually executing and delivering an outcome to people. Of course, the people that are talking about this stuff are also talking about like zero employee companies, like that's a goal that you should be shooting for. I didn't anonymize any of these because they don't deserve it. These people do not understand work, like to a degree that even Frederick Winslow Taylor and I would be like, yeah, these guys don't get it. Now, of course, the downside to all of the stuff I'm talking about means you need to go talk to people. Sorry. It's 2026, get over it. I can't, I've been talking about this stuff for 10 years now. I can't be quiet about it anymore. I can't be like hinty about like, oh, maybe you should do it. No, suck it up. Learn how to be a human. Learn how to engage with other humans in a meaningful way and talk with them. Sorry, that's the job now. But once we start having access to the users and the people using our software and what the uses to which the software is being put, now we need to start to take ownership of how our code is being used by the companies that employ us and by the people they're selling it to. You are writing tools for others to use to shape the world how they want it. Are you okay with how they're shaping the world? We need to develop professional ethics. We need to form a professional organization. I have a computer engineering degree. I mean, because I have a computer engineering degree, it means I got to take the fundamentals of engineering exam. Because I passed that, barely, it meant I got to join the Order of the Engineer, which is a US organization for engineers. It started in 1970. It is a thing that is basically the first step on becoming a professional engineer. If you want to be the kind of person that like signs off on building plans and structural engineering and aircraft and electrical circuits and such. The concept, or this organization started as a Canadian organization actually, called they have a ritual called the Calling of the Engineer, which is a fascinating name. It debuted in 1922. The ritual was written by Rudyard Kipling, because of course it was. The Canadian version started after the Quebec Bridge disaster of 1906, where faulty engineering calculations basically caused the bridge to collapse and kill some people. And then again, it collapsed in 1916, but that one wasn't their fault, basically. But they took the steel from this bridge, the iron from this bridge, and they smelted that into cast iron rings, meant to be worn on the pinky finger of your dominant hand. such that when you are drafting, because it is the 1900s and you are drafting on a paper on paper on a table, the ring makes a noise when you go across the drafting table, reminding you that if you screw this up, people die. Because the US has to be special, their rings are made of stainless steel, and apparently some colleges offer the option to get you your ring passed through a ring, which I didn't get, and when I learned this, I'm kind of mad about it. We have to have something that is similar. The obligation of the engineer, which is the thing I signed, is I am an engineer. In my profession, I take deep pride. To it, I own solemn obligations. As an engineer, I pledge to practice integrity and fair dealing, tolerance and respect, and to uphold devotion to the standards and dignity of my profession. I will always be conscious that my skill carries with it the obligation to serve humanity by making the best use of Earth's precious wealth. As an engineer, I shall participate in none but honest enterprises. When needed, my skill and knowledge shall be given without reservation for the public good. In the performance of duty and fidelity to my profession, I shall give my utmost. We don't have to copy this one, but it's not a bad start. I've spent a bunch of time while ideating about this talk and drawing the slide for this talk, thinking about what the equivalent of the ring would be for us. And I came up with a really obvious answer that's never going to fly. And the obvious answer is that if you want to click a keyboard, you should have to be in the club. But that's never going to work. Nobody's going to be on board with that. So what I'm actually trying to do right now, and I have a couple of prototypes at work that I'm playing around with, is offer some STLs for keycaps. For the colon, semicolon key, because that has, if you code Python, I can't help you. This has such meaning to our profession historically. And I'm just going to try and offer a couple different versions of it so that you have something that feels comfortable, but something that just reminds you on a regular basis, not, software, don't get me wrong, a lot of software isn't if you screw it up, people die. But if you screw it up, people's lives get measurably worse, especially if you're working on something that is a massive system driven by massive data, shipped and used by a lot of different people. But even the small things, even if you're building an app for McDonald's and it just doesn't work, and like the things are just a little slow or a little laggy, like that can be meaningfully bad to somebody's day. That can take somebody who's making a bad day and push them to an extent that they would not normally go to, right? Software, because it is everywhere, has such an outsized effect on our lives. We have to be willing to stand behind every line of code we commit, with our honor, with our reputation, and with our credibility. No matter who or what wrote it. If your name is on it, it's your responsibility. This is the only thing that is going to drive our industry forward. It doesn't matter if we produce code faster if it's the wrong code. It doesn't matter if it's more reliable if nobody's going to use it. It doesn't matter if it felt good to have written it if it's the wrong feature to have written. And it doesn't matter if it was the right feature if it's being used to accomplish dastardly ends. So, what could you do with this tomorrow? Well, first, start to use your boredom. Boredom, especially when it creeps in situations where you don't have a ton of stimuli, or when you are unable to focus on the things you want to, can actually be a tool. The fact that you get good ideas in the shower is because largely that is a stimulus-free environment. And your brain is like, oh my God, I need something. What do we have? It just digs through the big box of crap you've been thinking about over the last couple months and comes up with solutions to problems. If you've ever felt yourself just have like, oh, hey, yeah, when you were driving to work or some other situation where you didn't have to be paying much attention and your mind is just wandering, that's the power of boredom. Using boredom as a tool and learning to use it to propel you to novel solutions, not just technical ones, but ones that you go, hey, it'd be really cool if the app did this. That's a thing you can start doing. Start to work on elevating yourself up to that second order loop. And start that by asking questions. Understanding, truly trying to understand the people that you are building the software for, even when the people you're asking that of don't necessarily know the answer. Fight to bring back real Agile with a focus on real users and real people. The world isn't composed of KPIs. So let's bring this home. The boring nature of most software drives us to fill our work with complexity to keep our lives interesting. We face this problem because our ancestors made a dark bargain to give up control of what they coded in order to control how they coded it. We justify this drive toward overcomplication with the verdant ecosystem of new tools and methodologies. We need to reclaim the what, to once again become focused on value to the user from each piece of software, of code, of line of code that we provide. We need to let boredom push us to break the dark bargain that is holding us back. If companies have extinguished Agile, then let boredom be the fire starter that brings it back. I want you to become ungovernable, refuse to comply, to build code without a true understanding of the feature and what it is used for. Let's take back software from those who would use it for selfish ends. And let's find value on delivering features to people and trying to make the world and delivering on the promise of delivering software that makes the world a better place. Thank you very much for listening. If you want the slides, they're going to be at that QR code or the bit.ly link if you fancy typing for whatever reason. We'll do questions in a second. Thank you. Great. Anybody got questions? Sure.
You talk about using boredom as a tool and saying, my brain's not doing anything, it's thinking about these things that are on the edges and coming up with solutions as you're in the shower or driving or whatever. I actually thought about that today, and I thought of any tools that might exist for you to be kind of taking notes and being able to document your thoughts at that time very easily. Do you have any suggestions for that? Because those seem important.
I'm smiling because it's a problem I have encountered. When I first started getting into mindfulness meditation, I had very much the same thing. Like, that was really where I started coming up with some of the concepts around, oh, hey, when I'm trying not to think about things, or when I'm just paying attention to what my brain is thinking about, it gets bored real fast, and it starts coming up with all this stuff that I'm like, oh, I was thinking about that like a week ago. The problem becomes when you start to make that a goal-directed activity, your brain starts to go, oh, now I'm focusing on a thing again. It's kind of like you weirdly trick your brain out of the state you're in that moment.
Adding another framework to it.
Yeah, kind of. What I've found basically is just get better, like learn some memory tricks. It doesn't have to be like full mind palace level stuff, but something that will help you go, okay, I'm going to associate that thought with the place I need to be active about it, and then let it go and move on from there. That's an unsatisfying answer, I know.
Yeah.
I mean, or if you can hold it even just long enough to take notes after you've hit that moment, but I don't know.
For my example, from earlier today, for instance, it was being out on a run, and I don't have any like real technology with me. I have my watch and no phone, and I'm like, well, I could bring my phone if I had some sort of tool to do this sort of documentation of like, oh yeah, I should do that, or oh, that's a great solution for whatever, or
the best I can offer you at that point is if you need something, do it as low tech as possible. Like I know Aaron's got a notebook he takes notes in on a regular basis, like just in his shirt pocket all the time.
It's just a sheet of paper. Old sheet of paper.
What do you think a notebook is?
Yeah, because it runs a little bit of a longer thing than like a shower, but still from that, I would, especially if you're already in a case where I'm not taking tech, I'm not taking my phone, adding the phone into it starts to.
yeah, and if the phone did provide something, I'd be like, all right, fine, I'll get an armband or whatever I would have. If the phone would allow me to dictate or document.
You could go old school and see if you could find like a literal like cassette recorder.
Yeah, that's what I was just thinking about, like a recording device. But it's kind of weird to talk, your thoughts out and then listen to them later. But if that's the only option that you have, like when you're running. I mean, they make tiny little recorders, I guess.
You also get used to listening to yourself, just FYI. He says as he's packing up the camera.
Maybe send the audio file to Art for the transcribe and email back.
No, thanks.
Art, what are your thoughts on lean and the Toyota production system?
Okay. I'm sure, yeah. Let's condense this. So lean and the Toyota system especially are often inseparable in my head from W. Edwards Deming, because he was the one that drove a lot of the post-war Japan mindset on industry. And I posted on LinkedIn a while ago, like, if you see this talk and you're like, how do I do that? Like, what's the next step? W. Edwards Deming is the next step here. Especially his philosophy of total quality, like that stuff that he kind of did toward the end of his life is really about, like, he's the anti-drucker. Deming is all about understanding what the process is, knowing exactly how it works and exactly what your tweaks are likely to do to the outcome. I love lean as a concept. I don't think it applies well to software. I think if we were more diligent about it, like if we actually did MVPs as, will this work or not? Yes, okay, let's build the rest of it, instead of, will this work or not? Cool, that's enough for me to get my bonus. We're moving on to whatever. Or, hey, now there's been another client fire. Like, we're often not diligent enough with the actual assigning of the work or the organization of the work, which is ironic given that there's a whole bunch of people whose job is to organize that work for us. But that, I don't think like the Lean, the Six Sigma are often, they don't map well to the chaotic nature of software. And it's one of those, digression. The reason I say TypeScript won in the CoffeeScript TypeScript war is that TypeScript acknowledged that JavaScript sucks, and CoffeeScript could not acknowledge that JavaScript sucks. Like, that's literally the distinction, because CoffeeScript meant you couldn't actually use any. They didn't have that concept. TypeScript was like, all right, JavaScript is already hell. In order to have there be any kind of adoption, we have, like, for there to be a process to get to something better, we have to have this concept of any. And now if you use any in TypeScript code, I'll hit your hand, but it was necessary to kind of get to that part. In the same vein, like you have to, in order for us to move forward, we have to acknowledge that software is chaotic, that the digital nature of what we do makes it so that we can change things very quickly, which means that either people come to expect it or we use it to our advantage. And to ignore that, to pretend that we're building bridges isn't going to work, or cars isn't going to work, if that makes sense. And additionally to that, auto line, like, I've been on an assembly line, not a car one, but for making baked goods. Ask me about that over a drink sometime. We don't build assembly line stuff. Even in the cases where we're gluing plumbing together, we are very much like plumbers, where we're coming into a house and it's like, well, there's the drain stack, there's the vent stack, there's the supply. All right, I got to map these together now. We walk into a house and it's a different house. It's going to be different. As opposed to, we're doing the same thing every day, every time, so we know exactly how to identify quality and manage that way. I think that's as short as I could get that answer, sorry.
I mean, I personally, I kind of separate a little bit, like the code production system for quality management from Lean in my mind. And so, but just focusing on the Deming stuff, I would say that I think business people never really understood customers anyway. So they're like, yeah, this is a crapshoot for us. Why we let developers see that we're confused. We just want them to do stuff and we want to make the money and hold it all.
That's a good point.
But what's interesting is somebody who worked with Deming, Bob Mesta, took engineering practices and then went back into the business world and started creating a practice around things like understanding customer problems. And so,
I actually haven't heard that.
You've heard that? Jobs to be done?
Nope.
You've heard that? So he has a whole series of books around that, which was the tying question, because I assume maybe you read that stuff, which is, have you ever applied the Taguchi method to any of the work you've done?
I've never had the luxury.
Because the Taguchi method apparently is better than like A/B testing.
Okay.
So Taguchi method gives you a three-dimensional view of the problem that's shifting, where A/B testing just lets you shift one part of the system, which it doesn't include all the other things going on. So
Don't get me started on A/B testing and how we do that because it's not very.
yeah,
Well,
so
we're very bad at controlling.
definitely a whole series of books about. And the first one that introduced it was Competing Against Luck
Okay.
by Mesta and the guy who did who coined disruptive innovation, Clayton Christensen. So yeah, Competing Against Luck and then Demand Side Sales
Okay.
are probably two really good back-to-back books. And then Learning to Build, actually that would be one of the first ones. Learning to Build is a small book and it goes through Deming, Taguchi, a number of people, Christensen, and like their techniques and how he folds it in to engineering for business. So that's a pathway for engineers, and it was by engineers of like creating control, or creating not control, but understanding causal relationships, which is actually something as we were talking, I was thinking I wouldn't mind giving a talk on too. I could kind of present that as a way to understand. If you're a developer, why don't you like just get around all the business people that understand what's going on and see how you can create a method of understanding causal relationships and people's problem solving.
I would love to do that. Have you read A Knowledge Creating Company?
No, I'm actually not really that like
No, it's a.
academic and like learning a bunch of stuff. I just happen to try to solve problems and try to figure out what I was missing.
What do you think I do? That's.
Yeah.
No, I think you.
What? Yeah,
Learn Knowledge Creating Company.
Knowledge creating company.
Yeah, it's a.
Competing Against Luck and Demand Side Sales 101.
A knowledge creating company is where I got the tire metaphor. Because they were talking about specifically one of it's a couple of different case studies, and one of them is like the first bread maker, the automatic bread maker that worked, where the engineer who came up with the paddle at the bottom that actually got the right kneading, went and like apprenticed making bread at a hotel nearby that was famous for making bread for months until she kind of like had she got the muscle memory enough that was like, oh, okay, I understand. It's the twisting kneading motion. Anyway, if you like, the stuff you're describing fits right in that vein.
Nice.
Other questions?
Any book recommendations?
Oh God. Not a ton on this one. A lot of this is
You referenced a lot in there.
not as many as I normally do in terms of actual like. The only book I think I mentioned was definitely that one. If you really want to get mad at Frederick Winslow Taylor and all of that, Todd Rose's End of Average is really good.
End of average.
Mm-hmm. The End of Average, yeah.
And it means the end of statistical averaging, so it's kind of a play on words.
Yep. The main thesis of the book is basically that we misuse the statistical mean a ton by taking averages of things that are not, or what he calls jagged, where like one of the canonical examples would be like human intelligence. And then we can start having an argument of whether like generalizable intelligence exists. But the idea that human intelligence is a single factor as opposed to multiple different ones is pretty well understood. Yet we can persist on doing things like taking a statistical mean in terms of like the IQ. And of course it dives into like how Francis Galton and all of that underlaid a whole bunch of racist science that directly leads to the Nazis if you just want to get real even matter about the current state of everything. So maybe wait a bit for reading that book.
Take a break.
Yeah.
All right, I like the keycap idea, but I just kind of want to know, I hesitate to use the word manifesto. What's the pledge that goes with this that you can kind of distill these ideas and
I don't know.
Spread them?
It's a thing that I need to sit down and start coming up with a place to actually start talking about it, because this isn't a thing I can come up with on my own.
Sure, I think you might need a committee, but like the Agile manifesto is pretty concise.
It's a decent place to start, but it's easily abusable.
That's true. Like I said, they figured out and they made theirs how to make it punchy to get it to spread.
Realistically, I'm sitting from a perspective of like, if we can start to get to the point of just remembering that the software we build actually has a real world effect on people, instead of, because it is so easy, especially when there's multiple layers at this point of technical abstraction between us and the people using the code. It's too easy to get wrapped into it. And I speak from personal experience on that as well. because it's easy to. Part of the reason I talk about the stuff I do is because it is the hard stuff, and the technical stuff is easier, and that makes it more fun to play around with, at least for me. So,
I think the more you can ritualize it, the better it will be. Make people make their own keycap or something.
forge it from steel, Iron Man style.
There's enough 3D printers.
So to clarify, Art, you don't have action items for us on the topics of professional ethics and professional organization?
No, we're gonna have to figure this out ourselves. If I have an action item, it's basically sit back, think about it, and start a conversation with me, somebody else, on what you think the boundaries are. I mean, I gave this talk at work and had some people not push back, but resist the idea that they have to move across the boundary line. And I will be honest that I think it's fair that not everybody has to, but I think the bulk of us have to. And regardless, I think everybody, even if they're not engaged in that work on a regular basis, engaged in the work of moving across the line on a regular basis, should be part of the conversation, because it still has to become, if they're going to do what they do without moving that way, there has to be a pipeline of trust, of being able to trust that you actually understand what the real user is in the case. And I've been lucky enough in some cases to get access to real users, or to have clients who were more directly connected or had a really vivid idea. There was a particular app I was tasked with building for the Department of State that was, as described, it needs to be usable. If I grease an airman up, or if I lube an airman up with bacon grease and let him loose in the kennels, he still needs to be able to use the app. Was, I think, the exact phrase. So, I mean, that's the kind of connection I'm looking for. But to answer your actual question, as far as like direct action items, it's let's start talking about this stuff. I did not know how this is the third time I've given this. I did not know how it was going to land. People seem receptive, so let's start doing some stuff. I didn't want to start like launch the talk and be like, all right, let's all meet and talk about this, and nobody shows up, kind of thing. Just see how angry people get. Sure.
Two thoughts. I think part of the question is who gets a key. No, I'm just kidding. Who gets a key?
Oh, yeah.
How do we know? No.
I want to keep that.
We want to keep
what I
that.
have.
No, so the question is what about now that everybody's a coder? Like everybody's a vibe coder these days. So does that mean everybody gets to be part of the group now of developers? Like, it used to be you could just take a class online, learn JavaScript, and now you're a coder, sort of thing. I mean, you can't say that this is that much bad for that, because a person becomes a vibe coder, they're still gonna have to like learn or like figure things out, and that means that, you know, good and bad, everybody could, you know, could be involved in saying, hey, I code now. And then if you learn the terminal a little bit, now you're you know, you don't have to code front end stuff, you don't have to front end development. Now you're all of a sudden a back end vibe coder. Realistically,
I think the answer lies in the term professional for me, of in the same vein as like a professional engineer. If you're, you know, drawing out the framing and the loads, you know, calculations for your chicken coop, nobody gives a shit if you build that yourself. And you don't have to join a professional engineering organization to build that. In the same vein, if you're vibe coding apps for yourself, thumbs up. The second money starts coming into the picture, that's where I start.
Yeah, but people take a class on JavaScript and they start working in a company, and before you know it, they're like doing stuff. I mean, there's got to be a pathway.
Yeah, I mean, if we're
pathway. I really like something Bill Dye said, which is that, you know, it's kind of the same fear from assembly to like programming and higher languages and stuff. Is that the case? You got higher programming to like maybe, you know, AI assisted development. You still have to analyze whether things have gone the right way or not.
Yeah, I mean, you're making a lot of assumptions about
I don't know.
Deterministicness of the models, but no, I mean,
but the models write code. The code is deterministic, right?
fair.
Hard coding, I don't think you need the key. Oh. Yep. Well, that's the start. You don't get the key yet. You're at the beginning of the trail.
I mean,
you're working towards the key.
Okay, I saw your question. I'll get to it in a second. Just so you don't have to have your hand up. I think the real answer to the question is that is something that the organization would need to set up. Like, if we're talking about an actual professional organization, that would have, okay, you've met the criteria to be a member of this organization. In the same vein as a union would for, say, like the IBEW, you've got a certain level of, you have to go through an apprenticeship, you have to take these training courses, you have to qualify for these things. I explicitly did not use the word union in this talk because that has a lot of baggage to it. But the concept of there being a professional organization that understands that there is a curricula for training this stuff, whatever that happens to be, and that can adapt, the organization which can adapt itself to changing circumstances, because we are still a very young industry. As you know, like, the story starts in the 50s. So, but that's the kind of conversation I'm like, I don't have an answer for that yet, so we'll see where it goes.
Yeah, so kind of along those lines, I'm not sure if you've seen any of the talks that Maggie Appleton has given.
Mm-hmm.
She's given talks that talk about how software can be a home-cooked meal. And she used the analogy of, if you're cooking a meal at home, you don't need all of the tools and rigor that an industrial kitchen at a restaurant would need. Right? You're making a meal for yourself and your family. And like those LLM tools at their best can help you solve a specific problem that you as an individual have. But that's a very different structure than building something for other people to be using or for a class of people to be using. And bridging that divide does require rigor and professionalism, which we as like developers have. That, you know, your vibe coder that just downloaded Claude Code may not be able to, may not have. So that's where I feel like we still have a place, and that's how you kind of synthesize those.
Well, in addition to that, I mean, aren't we all using systems that would have been considered toys like in IBM's day? I mean, obviously there's a way more advanced, but I'm just saying.
Way more transistors than that.
The whole concept of like a personal computer, you know, versus a mainframe.
Yeah.
Thing. I mean, I would agree that, like, yeah, right now it's premature to just go out the gate, but there's going to be eventually practices put in place and like methods that'll be figured out that like 10 years from now, you know, whole, you know, industrialized types of operations will have a lot of AI.
I'm going to abstain from commenting, or we'll be here all night.
It's a guess. It's
Yeah.
not even based on anything other than
What were you saying?
determined kind of stuff.
I was just gonna say that I think we have even more of a role to play with all these vibe coders, because we're the ones that know what responsible coding is. We're the ones that are defining that. How much obligation do we have then to try to get them on board with this as well? Because they don't have the history that we have. They're just figuring this out, like, from nothing. So I don't think we want to gatekeep who could be considered a developer. But I do think that we want to help set those standards and hold people accountable, even if they're just vibe coding.
Yeah, I definitely think standards and accountability is important.
Yeah.
You know, I think that LLM stuff is like an extra capability, and you're just trying to figure out how it all fits together.
I mean, we basically like given everyone nuclear bombs, and we know how to use it responsibly, and other people don't.
I'd go with, I did, okay.
Maybe nuclear power. I don't know.
No, I was,
Something that can be used to cause great destruction, but also.
well, I was actually going to say, and this is okay, Bob Martin's got problematic views on a lot of things at this point, but one of the things he said that I still agree with, that I think is to some extent a inspiration for this talk, was he described how we're kind of like medieval monks. Like, we have literacy as a skill in a way that other people do not. And if these new tools, and I use the word if to ally to various discussion, provide that sort of literacy to other people in a way that the Gutenberg printing press did, what is it that makes our profession different? What do we bring to the table? And the whole thesis of the talk is that it is understanding what it means to write software and why we're doing it, and how to do it in a way that provides meaningful, good outcomes to the world. In the same vein as if I was writing, writing a book that's good versus writing something that is using the skill of writing for, say, like a William Randolph Hearst newspaper back in the day, like old school yellow journalism kind of thing, would be my equivalent of like, that's the danger, right? You can use these things to have an outcome that isn't great, but you can also use the same tools. 5 years ago you could have done the exact same thing. You just would have had to write it all by hand. Other questions?
There's an analogy, I just had an epiphany, there's an analogy to teenagers. Because when teenagers' brain is like growing quickly, it's like shoving parts of their other brain aside, so everything seems confusing. But they also have this like new capability of thought, but yet they don't have their frontal cortex developed enough. So the front is like the brake that allows you to stop and slow down.
We got them.
So you get this like exuberance. So we literally have like this like brain shifting moment of like all sorts of independent ideas, but without enough brakes.
Okay, I think we're about to get kicked out. Thanks again, everybody.
Good job.